All right, welcome, ladies and gentlemen. We're going to start with the heater formation. This concept's actually fairly easy, and it's one of those I'm going to build upon and use for the next couple of weeks in this chapter. And so with the heater formation, what we're looking at is the heat that's used to create compounds from the elements. So we take all our compounds, and if it's a straight element, the heater formation is 0. And so we take copper, we take O2, and we take H2, and we add them all together. And by magic, we get copper 2 hydroxide. And the heat, it takes 450 joules per mole for this to be, when this is created. In other words, it releases heat. So this is what we use. This is what we call the heater formation. And we're going to use these values to figure out the heater reaction. So when the heater formation of these compounds is known, the heater reaction can be calculated. So what we do is if we have A and B goes to C and D, then the heater reaction is each of the heat of these formations, D plus C minus A minus B. So in other words, what we have at the ending minus what we start with. And this is where we get the heater reaction. Now, if we have any coefficients in front of these, we've got to multiply, put the coefficients in front of each of these heats because these are per mole. So we have 2 moles of A, so we need to multiply this by 2, so on and so forth. So let's look at an example. I think if we put some numbers in this will show you how this works. For example, we got 2 Na, 2 sodium atoms, plus 2 water molecules gives me 1 molecule of H2 gas, plus 2 molecules of NaOH and water. So what we're going to do is that if we put this in water, we have 2 moles of sodium, or after 2 moles of water to produce 1 mole of hydrogen and 2 moles of sodium hydroxide. And we need to know the heater formation for this. Anytime we have an element, or elemental or diatomic element, Na or H2, N2, O2, and so forth, their heater formation is 0 because it's in their elemental state. Now the heater formation of water in a liquid form is minus 285.8. And then we have sodium hydroxide, we have a minus 470.1 joules per mole. And so we're going to take these two numbers and figure out the heat of formation. And excuse my cat is in the way. So when we look at this, I'm going to go back and forth. The heater reaction is equal to H2, which is 0. So 2 times 0 is 0. Plus NaOH, that's minus 470.1. And we're going to multiply that by 2. So this is going to put a 2 in front of this. Minus 2 Na, well, sodium's 0, so we don't have to worry about that. So we've got 2 waters. So minus 2 times 0, minus 2 times water, which is 285.8. And now we're going to figure out what the heater reaction is when this occurs. So 2 times, let me get my calculator. Thank you, Kat. 2 times 470.1, we get a minus 940.2. And thank the cat for that. 2 times 0 is 0, so 285.8 times 2. And that's it. And this is a negative 285.8, so this becomes positive 571.6. And when you add the two together, you got minus 368.6. Excuse me for a moment. Cat was on my drawing board, and you wonder why my drawing board gives me problems every now and then. Minus 368.6 joules of energy in this reaction. And this is the answer we're looking for. And notice with this heat formation reaction, we're already taking care of all the coefficients when we did all this multiplication. So for this reaction, as it's written, the heat of reaction is minus 368.6. All right, thank you guys, and have a nice day.